strange things that can happen when you're trying to factor a polynomial. And there's some shortcuts that you can use to get around those strange things that might happen. So let's say you have this equation, 5x squared plus 15x plus 10. If you tried to do that, you would do a times c, you'd get 5 times 10, that's 50. You'd be trying to find two numbers that multiply to 50 and add to 15. It might not be too bad, but those numbers can get pretty big pretty quick, and that's annoying. So here's a kind of a major step that I'm going to give you whenever you're factoring. It's really step one. You got to burn this into your brain. Always look for a GCF to pull out of this thing at the very beginning. Burn that in your brain. So is there something we can pull out of this? 5? 5 goes into all of these numbers, right? So I'm going to do that. I'm going to factor out a 5 before I do anything else. That's going to turn this into x squared. It's going to turn this into 3x. And it's going to turn this into 2. You know what I'm saying? So I saw that 5 goes in all those things. I factored out the 5. And now what I can do is ignore the 5 in front and just focus on this. And I can just factor that like normal. Now it's like a million times easier. Because what is the a value of this thing? It's 1. So now I'm just going to factor it like normal. 1 times 2 is 2. I need two numbers that multiply to 2 and add to 3. 1 and 2. Oh my gosh. Wow. And remember, if the leading coefficient is 1, what can you do? Just take the two numbers. The 5, nothing's happened to the 5 yet, okay? So basically, it's just going to stay in front. That's all it's going to do. It's not really going to do anything. Remember, if you want to do the whole process here, you can, and it'll work. But if a is 1, you can take your two numbers. You get x plus 2 and x plus 1. I haven't done anything to the 5, so it just comes down, slap it in front, and we're done. So, always, big thing here, always look for a GCF every time. Yeah, and you could do it like that. You could. Sometimes the numbers will be a lot bigger, and that gets annoying. So if you did it without taking out the GCF, it'd be fine. You still get the same thing. So if you could take out a GCF, take it out because it'll make life easier. All right, one more weird thing that might happen. Let's say we got one like this. X squared minus 25. This one is weird because it's missing a middle term. You know, you could think about this as x, oh gosh. So you could think of this as x squared plus 0x minus 25, right? Just go like we normally do. A is 1. I need two things that multiply to negative 25 and add to 0. That doesn't multiply to 25. What are things that multiply to 25? 5 and 5? But it's got to multiply to negative 25, right? Do those add to 0? Wow. And a is 1. Wow. Amazing. All right, I'm going to point out one more shortcut to you, okay? Listen up, guys, listen up. One shortcut here. You can always do the process. It'll work every time. You can always do a times c, add to b. Remember, if a is 1, you can take the numbers. If a is not 1, you got to do all the grouping, mumbo jumbo. If it looks like this, though, there is another shortcut that you can do. Technically, this thing is a special pattern. We call it the difference of squares. We call it the difference of squares. Basically, here's what it is. These are two things that have a square root, right? What's the square root of x? Or sorry, square root of x squared. It's just x, right? What's the square root of 25? 5. Well, that looks like what showed up in our answer, right? So if it's a difference of squares, two things that both have a square root, there's a shortcut you can use here. Just find the square root of both things and do plus and minus those pieces. Okay, let me show you another example of this. Let's say I have this one. T squared minus 49. You could do A times C add to B, and it would work. But what's the square root of T? Sorry, I mean to say T squared. You know what I'm saying. It's T. What's the square root of 49? 7. So it's going to be T plus 7 times T minus 7. Yeah. It has to be subtraction right here. Yeah. So if it was like that, it wouldn't work. Yeah. Yeah. If C was 0, we're going to do one like that in a second. Yeah. All right, one more of this that is a little bit complicated. Let's think about this one. This one's different now because A is not 1. That's fine. You can still do the difference of squares shortcut. What's the square root of 4x squared? 2x. What's the square root of 9? 3. So it's 2x plus 3 times 2x minus 3. You want me to prove it to you? Let's multiply this out real quick. Double distributing. If you don't remember how to do this, that's okay. We're going to do it more later. 2x times 2x is 4x squared. 2x times negative 3 is minus 6x. 3 plus 2x is plus 6x. 3 times negative 3 is minus 9. These things cancel. 4x squared minus 9. Is that what we started with? Wow. Holy cow. What are you questioning, Hazel? It's just a pattern that we have to do. Once you figure out what the square roots are, you have to do plus minus. Otherwise, it's not going to cancel, and it won't get back to what you want. Okay? So remember, this little shortcut I'm showing you, this only works for a difference of squares type problem. That means it's missing the middle term. Okay? You can't just do this all willy-nilly. It only works if it looks like this, or if it looks like this, or if it looks like this. Remember, if you can't remember the shortcut, you can still do the whole process and it will still work. I'm just telling you the shortcut so that if you want to use it, you can. Yeah. No. No, it has to be, that's why it's called a difference of squares. It has to be subtraction. All right, so like I said, if you can remember the shortcut, use the shortcut. If you can't remember it, then just do the process. Okay? Cool? All right. Okay. We have like 10-ish minutes left here, guys. I got to show you the reason why we've been doing all this factoring stuff. Okay? So the whole point of this new unit that we're starting is that we're taking quadratic equations and we're trying to solve them. So the last unit was all about graphing them. This one's all about solving them. So maybe you remember this from Algebra 1, maybe you don't. What does it mean to solve a quadratic, solve anything, really? To find something, right? Find what? Did you Google it? Oh, find it in yourself. Oh, I thought you said find the intercept. That is, in fact, what we're trying to do. Yes. Yes. Here's what solving a quadratic means. It means you're finding the x-intercepts. That's what we're trying to figure out. So when I say we're solving a quadratic equation, we're trying to find the x-intercepts. We're trying to find where the parabola hits the x-axis, okay? There are different words for this. We call them solutions. We call them zeros. We call them roots. We call them x-intercepts. They all mean the same thing. It's just where the graph hits the x-axis, okay? So from here on out, if I talk about solving a quadratic, realize that I'm talking about finding the x-intercepts. Yeah, you're not trying to find it in yourself. No. Maybe you're trying to find the motivation in yourself, which we're really searching hard for today. Yeah. All right. There's different methods that we use to do this, and we're going to talk about a bunch of them. That's really what the entire unit is just different methods of how we find the x-intercepts. Factoring is one of those methods, okay? So let me show you what I'm talking about. Before I got to show you one more thing, and then I promise I'll give you an example before you're out of here. Let's talk about this thing called the zero product property. Maybe you remember this from Algebra 1. There's a lot of words up there, but I don't want you to just like be a math student that just copies down words and remembers processes and doesn't actually think about what's going on, because that's dumb. I want you to actually think about what's going on. So let me ask you this. Don't even worry about this right now. You can write it down here in a second. Let me ask you this instead. If you have two numbers, A times B, you don't know what the numbers are. If I tell you that A times B equals 0, what can you deduce about A and B? No, go for it. One of them must be 0, right? Because if they multiply to get 0, then one of them should be 0. Could both of them be 0? Sure. So one or both must be 0. You can say that just based on that information. You don't know what A and B are. You just know that there's got to be a 0 in there somewhere. This right here is what we call the zero product property, okay? So all these words are just telling you exactly what we just deduced. If two or more quantities multiply to equal 0, then one or more of the factors must be 0. So let's look at it with some things other than just random numbers. Let's say I have some factors, x plus 3 times x minus 7. Let's say I tell you that that equals 0. Well, that must mean that one of these things or both of them equals 0. So in order to find out what they are, like what x is, we can set these two things individually to 0 and solve them. Yeah. No, so x can be two things because we're talking about a quadratic here. I don't want to talk about that. We're talking about a quadratic. This is telling us what the x-intercepts are. And a quadratic has two x-intercepts, right? So x could be two different things. Zero product property make a little bit of sense? Okay. All right. One more thing, and then I'll be done talking. You missed parabolas. How much time do I have? 8 minutes? Oh, plenty of time. We're going to get through this problem, and then you'll be done. Okay? We're going to solve this by factoring. Okay? First thing I got to do is write it in standard form. That means get everything on the same side. So right now, the pieces are kind of jumbled up, right? I want them to all be on the same side of the equation. Yeah, so I'd have to take this. I'd have to move it over. So I'd have to add 15 to both sides. I'd have to move that over. So in standard form, it would be 2x squared minus 11x plus 15. And it equals 0, because we're talking about an equation now. So I got everything on the same side, and it's all equal to 0. Oh, yeah, you can't combine those things. All right, step 2, we're going to factor it. So this is what we've been doing for the last 2 days. The leading coefficient is not 1, right? So I can't use the shortcut. That's fine. A times C, 2 times 15 is 30. I need two things that multiply to 30 and add to negative 11. What do you got? What are some things that multiply to 30? 5 times 6 might work, but it's got to get to negative 11. Okay, so negative 5 and negative 6 multiplies to positive 30, adds to negative 11. So I rewrite with those numbers. I group them. And then we look at GCFs. First one, 2x squared minus 5x. What can you take out? X. Can you take out a number? Nope, nothing goes into 2 and 5. So take out an x. It's going to be 2x minus 5. What about the second piece? So you can take out a 3, but since it's negative in front, you want to take out a negative number. So it'll be negative 3. What's this going to be? Negative 6x divided by negative 3 is 2x. And 15 divided by negative 3, negative 5. All right, so my final, I take the repeated factor, 2x minus 5, and the two GCFs, put them together. Okay, so all I've done is I got my equation and I factored it. Again, if you're not a pro at the factoring yet, that's okay. We're going to keep practicing it. But I got the factors. Questions on that yet? All right, here's the last part. This told me to solve. We're solving this. So I'm trying to find the x-intercept. So that means I need to end with like x equals this or x equals that. So this is not my answer. This is just the factoring. I got to do something with this to get x by itself. And we're going to use the zero product property to do it. So remember, this is all equal to 0 right now. So I can say 2x minus 5 times x minus 3 equals 0. Yeah, are you? Huh? What do you mean? How would you solve it? Well, you got x squared and x. How are you going to put those together? Well, up until now, we haven't solved an equation like this. Yeah, because I got an x squared, I got an x. I can't put them together to isolate it. So I got to do something else. Okay, so down here, I got these two things equal 0. Remember, the zero product property. This is the only new thing I'm telling you right now. Once you get to this point, you have your two factors. They're equal to 0. Split them up, okay? You can split them up and set them both equal to 0. So I have 2x minus 5 equals 0, and I have x minus 3 equals 0. Now, these are two equations that we can solve. On this one, I need to add 5. I would divide 2, and I'd get that x equals 5 over 2. So there's one of my x-intercepts. This one's really easy to solve. Add 3, you get x equals 3. There's the other x-intercepts. So these are the 2 points where this parabola crosses the x-axis. And I was able to find that by getting everything on the same side, factoring this thing, setting the two factors equal to 0, and solving them for x, and then we're done. And that's it.